Welcome to Getting Started in Visual Analytics. Visual analytics is the process of gaining knowledge and insight from data from interactive visual interfaces. This video covers the fundamentals on working with marks and building views. You can download the exercise workbook to follow along in your own copy of Tableau. There are two ways to start analyzing data in Tableau. You can either jump in and start exploring, or you can ask questions of your data and attempt to answer them. We'll start by asking of this dataset, Superstore, what are our sales like over time? If we simply double-click Sales and Order Date, Tableau uses visual best practices to create a timeline, and we see our sales are increasing over time. Note that the mark type here says Automatic. This illustrates how thinking of a practical question can be a good starting point for analysis, and how Tableau will try to automatically leverage best practices using the fields we're interested in. We could change this to another mark type if we had reason to do so. There's a long list of mark types available to work with, each of which has specific characteristics. One thing to note is if the mark type is automatic, it may change as the view is modified. Let's ask another question. What is the relationship between shipping cost, double-click to bring it out, and profit, double-click again? This time, we're given what looks like the start of a scatter plot. However, Tableau is aggregating our data to the overall sum of shipping cost and the sum of profit. So we have one mark, sum of profit by sum of shipping cost. If we'd like to see more marks, we can either disaggregate the data by going to the Analysis menu and unchecking Aggregate Measures to see each row of data plotted as a point, or we can bring another field out into the view to change our breakdown of marks. This is an important concept in Tableau. Measures, here, are automatically aggregated to the granularity of the view. The granularity is set by dimensions and how they're asked to interact with the marks. For example, if we bring Product Category to the Color shelf, we now get a uniquely colored mark per category, showing the sum of shipping cost and profit for that category. If we bring another field, say Market, to Shape, we get a mark per category per market for 15 marks. Dimensions define the number of marks, which we can always see down here at the bottom left. It's easy to change our mind and color by something else. If we want to have order priority on color instead, we simply drop it on the category pill with that color icon. Note that when we add order priority to color, we wound up with a mark per order priority per market for 20 marks. There are 4 levels of order priority and only 3 categories, so we wind up with more marks when we use order priority instead of category. Again, dimensions define the number of marks or the granularity of the view. If we want to make marks at a certain granularity, but without encoding by color or shape, we can bring the field to the level of detail shelf. It's important to know how adding dimensions to the marks card impacts the visual. The better understanding we have of this behavior, the more precisely we can build graphs manually or leverage what Tableau can do automatically. When we hover over the legend for order priority, note that this icon is shaded. This means that highlighting is on for order priority. If we click on a priority, say critical, Tableau will lighten the other colors to pull out the critical orders visually. Category does not have highlighting turned on. If we click on furniture, nothing happens. Clicking on the highlight icon turns this feature on. Now furniture is highlighted in the view. We can also show a highlighter for one or more dimensions that are not encoded by color or shape just by turning on the data highlighter. Right-click on a dimension in the view, such as Market on the detail shelf, and select Show Highlighter. Now we can highlight a market such as Asia Pacific, or any of the other markets in the view. highlighting can be a great way to call attention to specific marks. In dashboards, highlighting actions can provide interactivity even across worksheets using that field. In stories, highlighting can be saved to preserve a specific selection by updating the point. Another way to get started with visual analytics is to use Show Me. Control-click multiple fields you want to use. We'll use the same ones we were working with: order priority, market, shipping cost, and profit. And then open Show Me in the upper right-hand corner. Here we can see the one-click graphical options for representing the fields we've selected. The orange box indicates visual best practices. Remember, Show Me is just a starting point for creating visual analysis in Tableau. Once we have the basics of visualizations, we can use the marks card and many other features to modify the view to make it exactly what we want. Drilling down can mean a couple things in Tableau. Usually, it means expanding out a hierarchy, thereby drilling down to the next level of detail. We'll address hierarchy drill down for the majority of this video. Alternatively, sometimes drill down can mean going all the way down and looking at the raw data. This is very easy in Tableau. Either click this icon here in the data pane to see the underlying source data, or for a specific mark in the view, click to bring up the Tooltips command buttons, click the same icon, and go to the Full Data tab. The command buttons can be turned off in the Tooltip to prevent access to this feature in published workbooks if desired. But let's assume we want to easily expand out a series of dimensions to drill down, such as category to subcategory to product name, or country to state to city. Multi-dimensional data sources are limited to their pre-built hierarchies, but if the data source allows it, it's easy to build a hierarchy right in the data pane. Here we see there's already a clear relationship between category and subcategory. In the data pane, to build a hierarchy, all we have to do is select whatever field we want is the next level down, subcategory, and drag it on top of the first level field, category. We'll name this Products, and it's that easy. The first thing to note is that here in the pill in the view, there's now a minus sign. Clicking that will roll up our hierarchy, and now it's a plus to indicate there are more levels. Clicking on the plus expands it out. What if we want to make this go further? We can add product name to the hierarchy simply by dragging the field in the data pane underneath subcategory. Note the line showing where it will go. We can also rearrange the order simply by dragging the fields around in the hierarchy. Even though the hierarchy has multiple levels, we can still manipulate each level independently. We can remove subcategory from the view so that it just has category and product name. Note though, if we roll back up and drill down again, the view will redefault to whatever the hierarchy is in the data pane. What if we realize we don't want the drill down functionality anymore? We can either remove a field from the hierarchy simply by clicking and dragging it out, or we can right-click and remove the hierarchy altogether. Let's undo that, though. There may be instances when it's useful to have a field in a hierarchy, but also be able to use it on its own. For example, perhaps we want to create a high-level view, where drilling down to the lowest level of granularity could negatively impact performance without adding to the analysis. We want to be able to use a specific field without the drill down option. Simply right-click on the field, select Duplicate, and then use that field in the view. Now it has no drill down capabilities. Date fields, depending on their level of granularity, are automatically brought into the view as hierarchies. Here, when we bring out order date, it already has a plus sign, indicating that we can drill down. If the dates in the data are in a standard format, including year, month, and day, Tableau will recognize automatically the additional layer of quarters and build that out. As always, we can remove an individual pill that we don't want in the view. The default pill type for a date field is discrete, and a discrete date hierarchy will have a different pill for each date part. However, if we right-click and drag out the date, or change the pill type from the drop-down menu, we can select a continuous date instead. Continuous dates still have the same drill-down functionality, but each drill-down updates the pill to the next level down instead of creating a new pill, because continuous dates by definition cannot be considered as separate date parts. To drill back up, open the drop-down menu by clicking on the caret in the pill and selecting the desired level. There are several ways to sort. First, and perhaps easiest, is the quick sort on the axis. For views with an axis, hovering brings up the quick sort icon. One click sorts the bars descending, another click switches to ascending, and a third click clears the sort. This kind of sorting helps identify the top or bottom values in a pane within the context of how the view is built. What if we wanted to sort by descending profit? Profit is on color, not an axis, so there's no quick sort button. If we open the pills menu, there's no sort option. In this case, the toolbar buttons allow for easy sorting. Click on the pill we want to sort by, in this case, profit, then select the appropriate sort from the toolbar. We can also sort from the field labels. If we want to sort the regions, we can hover over the field label, which is the name above the pane, and choose to sort alphabetically or by any of the measures. If we want to sort the markets as well, we can hover over that field label and sort again. But sometimes we want to set our own sort. Here, the fields have an inherent order. Low should come after medium, and same day should be above first class. To do this easily right from the view, we can drag the headers in the view or in the legend. For the most control, however, we can sort from the pill itself. To control the sort from a pill, unlike when using the toolbar buttons, we don't click the pill of the field we want to sort by. We click the discrete pill that we want to have sorted. Here, we want to sort our subcategories. So we right-click this pill to get the drop-down and click Sort. We can fine-tune exactly how we want to sort, such as alphabetic or manual, but we can also sort by field. And the field doesn't even have to be in the view. We can pick quantity and set the aggregation and choose our sort order. I like descending. It's also possible to sort different pills different ways. With that sort on subcategory, we could also sort category by ascending sum of sales. A sorted pill has an icon on the right side, so it's always easy to tell if there are sorts in the view. Perhaps the handiest thing of all, though, is the ability to clear the sorts. Come to the Clear Sheet icon here, and in the drop-down, select Clear Sorts. If we have multiple dimensions in the view that don't have a hierarchical relationship, we have to think carefully about how we want to sort. For example, here we have market and region. Each region falls into exactly one market, so if we sort by profit, everything appears as expected. But here, we have ship mode and order priority, and the order priorities span multiple ship modes.
If we sort order priority by shipping cost from the field label, all that Tableau considers is the shipping cost per order priority. And clearly medium orders have the highest shipping cost overall, so medium is brought to the top in each pane, even if for some ship modes, high priority orders have greater shipping costs. When we sort by field label, we're sorting across the panes, so to speak. And each pane, ship mode, will have the same order of the next dimension that's being sorted, order priority. By contrast, a nested sort, which is the default behavior when sorting from the quick sort icon, simply sorts each bar within each pane. The longest bar in the first class pane, high priority orders, is first, independent of the fact that for standard class orders, medium priority orders are first.
Have you ever tried to do an analysis with data that's less than perfect? What if we have both the postal abbreviation FL and the full state name Florida, but we want our analysis to consider them as the same thing? Or we may not care about the smallest office supply subcategories individually. Grouping lets us create a new field based on a combination of members. Let's say our data contains both FL and Florida. We know these are the same thing, so we want to combine the records into a group. It's as easy as control-clicking on the headers, and in the tooltip, clicking the paperclip icon. The automatic name is a concatenation, but we can right-click and edit the alias to just say Florida. Or we can group those smaller office supplies, but this time from the data window. We'll right-click on the field we want to group within, subcategory, and click Create Group. Now we can choose the members we want to group: envelopes, fasteners, labels, paper, and supplies. We'll click Group. We can rename this Small Office Supplies. If we notice we left out a member, we can select it and add it to the group using this drop-down. There's even a powerful Find option to help us search fields with lots of values. Once we click OK, the new field shows up in the data window with the paperclip icon and the word Group tacked onto the end. And this field is ready to use. If we ever realize we need to modify the group, we can right-click on that grouped field and select Edit Group. This brings us back to the editing dialog. If we right-click on the pill here on the Rows shelf, we see the option Include Other. This is also available in the original dialog box. Selecting this creates a group of any non-grouped members. This can help emphasize our original group, but I'll undo that. Once we have a grouped version of a field, we can use it instead of the original. Note that we still have the original field unchanged. The grouped one is in addition. For example, let's say we want our small items version of subcategory to appear in the hierarchy. It's as simple as dragging that field into the hierarchy list, and if desired, dragging out the original. The grouping will now stay with us as we drill through the hierarchy. What if we don't want to actually combine values into a new mark? We just want to call them out somehow. We can create a visual group. This is done by selecting the marks themselves instead of the headers and clicking the paperclip icon. This can be handy in views like scatterplots. Here, the marks that are selected are grouped and assigned a color, with everything else becoming other. If the marks we've selected span several dimensions, we can group by all or a particular dimension, say ship mode. Here we've grouped all the other marks in the view that share those values for ship mode. If we don't want that grouping across dimensions and we just want the marks we selected, we simply choose all dimensions. visual grouping has a downside that the grouping is static. Let's say, for example, we want to have a group of subcategories whose profits are over $100,000. We currently have a visual group for this, but it's static. And if we remove our filter, we see that it's no longer accurate. Instead, let's create a calculation. In the data pane, right-click and select Create Calculated Field. We'll name this High Profit Subcategories. And for the formula, we'll put if sum of profit is greater than 100,000, then above 100K, else below 100K, end. Now if we put this field on color, unlike before, as our data updates, any subcategories whose sum profits are at least 100,000 will be colored appropriately. The example we just did is dynamic as the data changes, but the calculation itself is static. Parameters can be used to make the calculation interactive. We'll add a threshold parameter to determine our cutoff for being in the high profit subcategory group. First, right-click in the data pane and select Create Parameter. We'll name the parameter Threshold, and we'll leave the data type as float, and all for allowable values, but we'll set the current value to 100,000. Click OK, and then right-click on the parameter and select Show Parameter Control. Next, we need to create a calculated field, otherwise this parameter isn't connected to anything, and changing the value won't make an impact. We'll right-click in the data pane and select Create Calculated Field. We'll name it Parameter High Profit, and for the formula, we'll use a variation of what we did before. Here, instead of typing 100,000, we'll bring in our parameter. Now, if we bring this field to color, not only will the group update as the data is refreshed, but the end user can modify the parameters, controlling the cutoff for membership in that group. Sometimes an analysis calls for grouping values of a measure into bins. A classic example is age groups. A person's age can fall anywhere on a spectrum, so it's continuous. But we often see surveys asking us if we're 18 to 25, 55 or over, etc. It's very easy to create bins. Here, we'll create bins for our sales measure. Right-click on that field in the data pane and select Create Bins. We see the range of values for this field automatically, and Tableau has suggested a default size for the bins, but this is easily edited. Let's make it 1500. When we click OK, we've created a new dimension because dimensions are how we break our measures into categories, which is exactly what we want the bins to do. Now we can use this new field. We'll bring the bin field to columns and the sales field to rows. As a note, bin labels indicate the inclusive lower limit. Sets are a powerful analytical tool in visual analysis. Let's say I'm a local manager focused on corporate customers in the Latin American market. In this viz, I have the number of orders the entire organization has gotten over several years. I want to see if my customers follow this trend. I've created a set of corporate customers in the Latin American market. By bringing the set to color, I can immediately see that we didn't have the same dramatic upswing in orders as the company overall. I should look into why that might be. Sets in Tableau can be thought of as combinations of data, like filter results. Here, it's the combination of only corporate customers, only in the Latin American market. Sets can be created by the user in Tableau Desktop from specific data in the view, or created via a calculation. They will appear in the data pane at the bottom, labeled with the set icon of 2 overlapping circles. Sets can have slightly different icons depending on how they're created. Some data sources may already contain sets when they're brought into Tableau. These will be indicated with a database icon together with the circles. Additionally, certain actions, such as filter actions on a dashboard, may create sets. As a rule, you as an author won't need to interact with these action sets. Tableau creates them automatically to ensure proper filtering across views. Last, user filters for published workbooks have a user filter set icon. Now let's build some sets. First, we can simply select marks in the view, say, high discount orders, and with those marks selected, click the set icon in the tooltip. This is similar to creating a group. We'll name the set High Discount Orders, and that's all there is to it. Sets made from marks are called constant. Constant sets are quick and easy, though as the name suggests, they are not dynamic. Let's create another set and look what options we have with constant sets. Because we're creating this set the same way as high discount orders, we could choose to add or remove these marks from that set. But let's just create a new one. One option we have here is to exclude. This will make a set of all the marks we did not select. Sometimes it's much easier to select the members we don't want in the set. We could also X out any of the dimensions that are currently being used to define the set. Remember, sets are like filter results. If we remove a dimension here, we're removing it from the requirements to be in the set. If we X out everything but month, we'll get a set of all the orders in the months that held the points we originally selected. Let's take order priority off color, changing it to a detail so we don't lose that information, and bring this new set to color. We see what's in this set. Note that month is a discrete date part, so despite the fact we only selected marks from 2012 and 2013, we have members in this set across all 4 years in the viz. If the analysis requires a set whose members are dynamic and update as the underlying data changes, the set needs to be computed rather than constant. For example, if a set is defined as customers whose name starts with A or orders whose average discount is over 8%, we likely want this to update as we get new customers or new orders come in. To create a calculated set, right-click on the desired dimension in the data pane. We'll use Order ID, and then we'll select Create Set. We'll name this Discount Greater than 8%. Next, we need to determine the condition for the set. The Condition tab can set rules, such as the discount field, averaging, over 0.08, which is 8%. If we wanted to enter a formula like customer name starts with A, we could put it down here. If we bring this set to color, we see that yes, profit for these orders is a bit lower than the overall trend of the data. Sometimes our questions can't be answered easily with a single set. Combining sets brings additional value and power to the analysis. Sets based on the same dimension can be easily combined. In the data pane, we'll right-click on one of the sets and select Create Combined Set. We'll name it very creatively Combined Set. Select the second set from the drop-down. Note that not all of our sets are listed. If the second set we want to combine is not available in this drop-down, the sets may not be based on the same dimensions. For example, our set A, negative profit orders, can only be combined with other sets based on order ID, not something like a set based on customer name or a set made from marks in the view. If we have these two sets, A and B, the possible combinations are all members in both sets, known as A union B. Here, any orders that are either negative profit or high shipping cost will be in the combined set. Shared members in both sets, known as A intersection B. Here, any orders that are both negative profit and high shipping cost will be in the combined set. Except shared members is direction specific, so it has two options. Any negative profit order that is not high shipping cost, or any high shipping cost order that is not negative profit. We'll go with this one and select OK. Once made, combined sets function just like any other set. And combined sets that are built off of dynamic sets continue to be dynamic. Sets can be edited, but to what degree is dependent on how they were created. If a set was created from marks, such as LATAM Corporate, right-clicking on the set and selecting Edit Set will bring up the list of requirements to be a member, and the only option will be to remove individual requirements. Members cannot be added to this existing set, though a second set can be created for the desired new requirements, and the two sets can be combined. If the set was created from a calculation, such as customers with A names, right-clicking and selecting Edit Set will bring up the same dialog that was originally used to create the set. This can be modified and saved. If the set was created by combining sets, right-clicking and selecting Edit Set will bring up the combination window. This can be modified and saved. Sets can be used like any other field, but they have the additional feature of in-out versus members. By default, when a set is brought into the view, say to color, the marks are colored for which fall within the set and which are not in the set. By contrast, if we change the set to detail by clicking on the color icon in front of it and selecting detail, then right-click on that pill and change the mode to show members, we're now only looking at members of the set, and the filter shelf shows that we're actually filtering by that set. Sets can be thought of similarly to filter results. If there is a subset of the data that can be thought of as a useful set, or a frequently used combination of filters, it may be worthwhile to create a formal set from these filter results, and then use the members of that set instead of constantly evaluating filters. When a set is first created like so, there's an option to add to the filter shelf. This immediately then uses only the members in that set. This is the same behavior as using show members. Alternatively, to create a set from a single filter, right-click on the filter shelf's pill and select Create Set. Note that if we were to remove all of these other filters, this set shows exactly those same filter results. Like groups, sets can be added to hierarchies. We can drag LATAM Corporate into the products hierarchy. Now when we drill in the bar chart, we see the only place that has in bars is LATAM, and the smaller bar here is for corporate sales. Sets can also be used in calculations. Here, we have a set based on customer names that start with A. If we wanted to know the profits from only these customers, all it takes is a simple calculation. Right-click on the set and say, Create Calculated Field. We'll name this A Name Profits, and the formula will be a simple if statement. If customers with A names, then profit. End. This will check to see if a customer is in the set, and if they are, it will return the profit for their orders. This is a very basic example, but using sets in a calculation like any other field gives them a lot of power in the analysis. At the most fundamental level, set actions take an existing set and update its values based on a user's actions in the viz. The benefit of set actions comes into play based on how that set is used in the view. Set actions, like parameters, allow the consumer of a visualization or dashboard to control aspects of the analysis. Like changing the value in a parameter control, visually selecting marks in the view updates the values in the set. In both instances, the parameter or set needs to be tied to the visualization somehow, such as by using them in a calculated field in the viz or placing directly on the color shelf. However, parameters have certain limitations that set actions avoid,
such as the fact that sets can be created conditionally or explicitly. They can contain multiple marks. And perhaps most powerfully, set actions allow sets to be updated visually by selecting in a viz, rather than by using a parameter control outside the flow of the visual. Using set actions is easy and intuitive, and creating a set action is easy as well, but it can be a little tricky to make sure you use it appropriately in the view to get the interactivity you're expecting. Let's go through the anatomy of building a basic set action. We'll create a set action that will update the color palette based on the marks selected in the view. First, we need to create the set. Right-click on the field this is based on, in this case country, and select Create Set. We'll name this Selected Countries. Note that whatever value we choose for the initial set doesn't really matter. As the set action, we'll change this. It's merely a placeholder. For more information on creating sets, check out the videos Creating Sets and Working with Sets. Next, we need to go to the Worksheet menu and select Actions. This will bring up the Action menu for the sheet. Note that all actions for this data source will be shown here, so if you're creating a lot, be careful with naming to avoid confusion. Click Add Action and choose Change Set Values. Third, we need to configure the set action. We'll give it a name, Set Color. Pick which dataset or sheets it applies to. Here, try it yourself. For Run Action On, I prefer Select, which is clicking in the viz. For Target Set, we again pick the relevant data source and the specific set. Finally, for clearing the selection wheel, we need to choose between three options. This can have a significant impact on how the set behaves. Here, we want to default to all the countries when a specific mark or marks aren't chosen, so we'll pick Add All Values to Set and click OK. Now we have our set and set action set up, but as yet it's useless. Yes, we can update the members of the set by clicking or selecting in the view, but that doesn't impact anything other than the set itself. We need to tie the set into the viz. This can be done any number of ways. We can use the set directly, such as bringing it to the color shelf, or we can use it indirectly by way of a calculation or analytical object. Color palettes are often distorted by extreme values. When one country has a higher value than other countries, the nuance of differences between those non-extreme values can be lost. We'll use our selected country set and set action to remedy that. By creating a calculation that looks at shipping costs only for the selected countries, and using that calculation on color, we'll avoid the distortion of the higher cost countries. First, right-click in the data pane and select Create Calculated Field. We'll name it Country Shipping Cost. For the formula, we'll enter if selected countries, then shipping cost, end. This will only return the shipping cost for countries that are in the set. Next, we'll bring this calculated field to the color shelf. To start, the color palette will seem exactly as it was before. But if we select the lasso tool and select countries in South America, we'll see the color palette updates to reflect just the variation within those countries. Clicking off to deselect those marks returns us to the default. This viz is fairly straightforward, but set actions can be used in extremely powerful ways that can get a bit complicated. The best way to understand how to bring a set action into a viz is through examples. Here, this dashboard is built with many relative date calculations. Based on a target date, the dashboard displays the difference from the previous day, year-to-date sales, etc. As we click in the timeline, the target date is reset. Here, a set is built on the date field with a set action that updates the selected date to be the only value in the set. A calculation is created that captures the date value from the set, and that calculated field is what is referenced by all the other calculations, which update the rest of the values on the dashboard.
There are a few basic ways to filter in Tableau: on the filter shelf, with an interactive filter, or in the view. First, we can drag a field such as category to the filter shelf directly. Here we'll remove technology. Second, if we want to let the user interact with the filter, we can use an interactive filter by right-clicking on the field. We'll use order priority and selecting Show Filter. And here it is in the view. Note that the filter does not have to be a field in the view. We added this interactive filter just by right-clicking on the field in the data pane. Adding an interactive filter puts that field on the filter shelf. Third, in the view itself, we can select a mark or group of marks, then click to bring up the command buttons in the tooltip, and keep only or exclude. We can also click on a header to see those same options. If you're in a view with headers, such as a bar chart, you can double-click on a header to keep only that one. Keep only and exclude can also be done from some legends by right-clicking. All of these types of filters put a pill on the filter shelf. To remove a filter, drag the pill off the shelf. Filtering is a complex topic. For more information on using the filter shelf, including the options that are presented for dimensions, measures, and dates, check out the video on using the filter shelf. There's also a video specifically on interactive filters, which covers how to create them and options for customizing and formatting. Filtering can be done at the record or row level in the data source, or in the aggregated view, or before the data even comes into Tableau. Let's say we're looking at this breakdown of our sales data, and we want to filter based on market. We can drag the market field from the data pane to the filter shelf, and select how we want to filter. Maybe we want to exclude our domestic market, USCA. We'll clear everything else, select Exclude, and choose what we don't want. That's it. We've filtered our view. But let's look into this a bit more deeply. If we right-click on that field on the filter shelf and click Edit Filter, we can bring the dialog back up. This is actually a very powerful window. Let's go through some of the features. Note that the options presented when filtering varies by pill type. For a full explanation on pill types and their impact, see the pill type video in the Why is Tableau Doing That section. This is the dialog we get when we're filtering on a discrete dimension. The first tab, General, lists all the values in the field we're filtering on. We can select all or none with these buttons, and we can either choose what we want or, using Exclude, choose what we don't want. If the list is very long, we can even search, like so. Use All can be a useful option if the list of members in this field may change and we want to ensure that we're always including every member as an input to the filter. Wildcard lets us filter very specifically. Maybe this field is email addresses and we want to exclude our company's domain. By saying Exclude, then choosing Does Not End With, and entering @tableau.com. This would filter out our employees. Condition lets us filter based on another field. First, let's cancel this and instead filter on product name, as this illustrates the concept a bit better. For example, let's say we only want our view to include products whose average quantity sold is greater than 1. We can do that on the Condition tab by setting the field to quantity, changing the aggregation to average, the comparison to greater than, and entering 1. If we want to make sure that this condition makes sense, Load brings in the range of values for this field so we can see what we're working with.
The Condition tab can also accommodate calculations, here by formula. If you're familiar with SQL, condition is like adding a having clause to the where. Top also lets us filter based on another field, and we can choose the top or bottom. If top filtering is giving you unexpected results, check out the video Filtering for Top and Top N. Filtering can be made more dynamic using parameters instead of constants for these conditions. There's a video on parameters with more information about creating and using parameters. That's filtering discrete dimensions. When we bring a measure like shipping cost to the filter shelf, we get a different dialog window. If our field is a measure specifically, first we're offered the filter field and asked to specify a level of aggregation. For a discussion on aggregate versus record level filtering, please see the video Where Tableau Filters. For now, we'll click All Values. And now we're brought to our options for quantitative filters. Range of values lets us select an upper and lower cutoff. The pre-filled limits are based on what's in the data source and how our view is built. Let's see what that means. Here, our view contains furniture for the LATAM market, and we see our shipping costs range from about $1 to $810. If we change this option Show from Only Relevant Values to All Values in Database, we see that we have some products whose shipping costs range up to $933. At least and at most are useful options if you only need to specify a lower or upper limit. Let's take a look at another example. Right-click on the pill on the filter shelf to see how the filter is set up. Here we have a filter on profit, and the lower range is set to 0 to filter out unprofitable marks. If we click OK, we'll see how that looks in the interactive filter. But watch what happens if we roll up to product category. We've inadvertently locked our upper range as well, and we filtered out 2 more profitable categories. Let's go back to that filter. And here we see that trimming. We should actually use at least 0, as this allows our upper range to fluctuate as we adjust the view. Lastly, for quantitative filters, we have an option for special. This helps us filter on nulls. That's filtering quantitative data. Dates deserve their own mention with filtering. When a date field, identified by this calendar icon, is brought to the filter shelf, we're given a filter field just like with a measure and asked to specify how we want to filter the date. A discrete date is treated like a dimension, and there are specific discrete date parts listed here. Note that they're in blue. Continuous dates, however, have their own date-specific options. Here we can pick range of dates or relative date. These will bring us to the options for continuous dates. Relative dates let us set a specific unit of time. Maybe we'd like to look at the last 2 years. We can set ranges, including things like week to date. By default, the filter is anchored to today, which is dynamic, but we can also change it to be anchored to a static date. Range of dates, starting date, and ending date are similar to measures, but with calendar date pickers. The interactive filter for a continuous date comes up as a range. We can use the slider or click on the date to bring up a calendar picker or to type in the date. Ranges are inclusive. The data for boundary dates will be shown. Dragging a field to the filter shelf is an easy way to filter. But what if we want to be able to modify the filter selection directly from the view? If we right-click anywhere we see Subcategory and select Show Filter, the field is automatically added to the filter shelf, and we get an interactive filter in the view. We can edit the appearance and functionality of the interactive filter by clicking on the caret to bring up the menu. Interactive filters can be applied across specific worksheets, all views using that data source, or across related data sources.
Under Customize, we can control if the option to select all is showing, as well as those floating control buttons like Search, or we could even add an Apply button. The title can be toggled on or off, or edited. It's often good to put an action word in the title, something like Choose a subcategory. We can also change whether selections made in the interactive filter are included or excluded by the filter. The mode or visual layout of the interactive filter depends on what type of field is being filtered. There's a lot of options for discrete dimensions, including single value lists, multiple values, drop-downs, and wildcards. How the interactive filter is laid out can impact things like space and interactivity on the dashboard. Drop-downs and wildcards save space, but lists may be more intuitive to click through. The interactive filter for a continuous field, such as shipping cost, has different layout options, including a slider, or at least or at most. If we create an interactive filter from a continuous date field, we get some cool options such as relative date, starting date, or browse periods. Picking a filter layout should be based both on the screen real estate and also thinking about how the filter will be used. The filter layout should mesh with the purpose of the dashboard. Another useful option in the menu is Only Relevant Values versus All Values in Database. All values will always show every option for the field, regardless of any other filters. A good example of when this is useful is something like cascading filters on a map. If we add an interactive filter for country, see how long this list is? Let's open up the menu. And note Only Relevant Values has been selected. So if we pick a market from the filter, the list of countries shortens considerably because it only includes countries for a selected market. Let's change it to a single value dropdown, which automatically selects just a single country. Note that the market filter collapsed. It only shows the relevant market to the country selected in the filter. That's because Only Relevant Values has been selected. If we always want to be able to select any market at any time, we can go into this menu and select All Values in Database. Cascading interactive filters are a great way to get interactivity into your analysis, or to tidy up long lists of values to make it more intuitive for the end user. However, they do require more work for the queries back to the database and may impact performance. As a note, hiding the quick filter does not remove the filter. It's necessary to remove it from the actual filter shelf, or from the menu of the quick filter. Interactive filters are a great way to let the end user interact with the visualization. Do note, however, that excessive numbers of interactive filters may slow down the performance of a dashboard or workbook. An important question to ask is, where are we filtering? Are we filtering to limit what we bring into Tableau from the start, or are we filtering our view based on summarized or row-level data? Most views in Tableau are built at a summary level. Here, the profit data is aggregated as a sum to the subcategory level. Note down in the bottom left corner, we have 17 marks. And based on the view, we can see that 8 of them show negative profit. If we bring profit to the filter shelf, because it's a measure, we're asked how we want to filter, all values or by an aggregation. If we filter based on sum, like our view is set up, and say at least 0, we wind up with 9 marks. Those subcategories with negative profits have been filtered out entirely based on the sum of profits at the subcategory level. If we change the granularity of the view by drilling down to product ID, we're still filtering out any mark at that summary level with a negative profit. Look down in the bottom left corner. Note how many products have a positive sum of profit. If we take off the filter, see how the number of marks jumps. Summary or aggregate filtering is essentially saying, Filter out any marks in my view that are outside the constraints I set. Stepping outside of Superstore, this can be useful in scenarios such as doing an analysis of movies where the opening weekend grossed over a certain amount overall. Alternatively, we can filter at the record level. Keeping with our movie scenario, this might consist of filtering out all individual ticket sales at discounted prices and looking only at trends for full-price admission. When we bring a measure like profit to the filter shelf, selecting all values will essentially exclude any record that falls outside the filter we build. If we set our minimum to 0 like before, we're computing our view using only rows that have a profit of 0 or greater. In our current dataset, each row represents a transaction, so we're only looking at profitable transactions. Remembering back to when we filtered on sum of profits greater than 0, at the level of subcategory we only had 9 marks. Here, when we filter on records with a profit greater than 0, we still have our original 17 marks. But those marks are composed only of data from profitable transactions. Instead of filtering out unprofitable subcategories, we're filtering out unprofitable records. Record-level filtering has very different implications and applications than summary filtering. Always consider where you actually want to filter when you're working with measures. Last, it's possible to filter from the data source level. What if we wanted to publish a dashboard for a manager to look only at their market's data? We could use permissioning or user calculations with Tableau Server or Tableau Online to do this, or we could filter to just that market with a data source filter. To create a data source filter, right-click on the data source itself and click Edit Data Source Filters. This can also be done when we're originally creating the connection. We'll add, and a list of fields is brought up. We'll select the one we want to filter on, mark it, and click OK. Now we can select the market we want. We'll choose Europe. Note that we have nothing on the filter shelf, but we only have countries in the view that are in the European market. Data source filters apply to all sheets using the data connection, so be careful when using these. Filtering in Tableau is incredibly powerful, but with that, it can get complicated. This video assumes a basic understanding of filtering is laid out in the previous videos and goes beyond into some deeper concepts. First is context filters. One thing to note about the filter shelf is that filters are computed independently of each other. If a given filter will trim the dataset down, it may be worth adding to context. A context filter will be computed first, then all other filters will run only on its results. For example, if we knew that we only wanted to look at products within the machine subcategory, we could make this a context filter by right-clicking and selecting Add to Context. The filter is now gray, and any subsequent filters will only be on machine products. Context filters are generally best to use when they'll return a significantly smaller set of results. The guideline is about 1/10 or less of the original data. Context filters ideally should not be something that would change frequently, so let's hide this interactive filter. When a pill is placed on the filter shelf, by default, that filter applies only to the current worksheet. If it makes sense to have the filter applied more broadly, we can change the scope by clicking the Pills drop-down, choosing Apply to Worksheets, and applying this filter to all using related data sources, all using this data source, or selected worksheets. This can be especially useful on a dashboard, where a filter that is relevant to multiple views can be set to apply to all or some of them simultaneously. By default, the interactive filter applies only to the view it was brought out with. But if we go to the menu and say, Apply to Worksheets, all using this data source, now all the views filter. And not just the views on the dashboard. Let's build a new sheet. We'll double-click Sales and double-click Category. In the view, note that we only have one category. Fortunately, we get this visual indication that a filter has been applied. This icon lets us know that there's a filter on the data connection, so we can backtrack and hunt it down if it's not what we want. Another solution would be to say, Apply to Worksheets, Selected Worksheets, and just target the ones we want to filter. It's important to note that taking an Applied to All filter off the filter shelf removes it from all views, not just the one we're looking at, so be careful when using this option. Because we have the power to control exactly what is filtered on and how, it's important to understand how filtering is performed. Let's say we want to run a promotion for customers who purchased more than $10,000 in sales. A straightforward way to do that might be to build a view of customers by sales, like we have here, and filter for sales. Sum is at least $10,000. It looks right, but this summary filter of sales over $10,000 is dependent on the structure of the view. If we modify the view, we risk altering how the filter is applied. Here we have 12 rows, indicating 12 customers eligible for our promotion. But if we break it out by category on color, suddenly we're down to 6 rows. Why? The 6 customers that were filtered out didn't have over $10,000 in sales in a single category, even if they may have been eligible overall. Tableau ran each mark past the filter. There's a mark per customer per category in the view. Alternatively, we could bring customer to the filter shelf and use the Condition tab to say we only want customers who have sales greater than $10,000. We have the same initial 12 rows, and if we again break it out by category, we still have 12 rows. No customers were filtered out like they were last time. Here, Tableau ran customers by their sum of sales through the filter. Then any who had more than $10,000 were put into the view, regardless of how categories split up those sales. Knowing how we set up our filter will impact how we can manipulate the view and maintain the filter as we designed it. What order filters are put onto the filter shelf has no impact on the query sent to the data source. All filters are grouped together in the Where clause. However, filters are applied in a fixed order of operations. Filters created during the extract process limit what data is brought into the extract itself. Then, data source filters are applied, limiting what is made available in Tableau. Once the data is in Tableau, context filters are applied first, and all subsequent filters are run against their temporary table of results. Filters involving fixed LOD expressions are evaluated next. Then filters on dimensions, like ship mode. Then include or exclude LOD filters. Then filters on measures, like shipping cost. And finally, table calculations, which are applied last because these are performed only on data in the view. Inefficient filtering is one of the most common causes of poorly performing workbooks and dashboards. For detailed information, see the related materials below this video. Some things to consider about filtering and its impact on performance. Context filters are slow to create or change due to the temporary table being created behind the scenes. But once they are in place, they can increase performance, since further queries are run only off a subset of the data as opposed to the entire dataset. Cascading interactive filters can help narrow down the list of options. Like here, we only see states that are in the country we've selected. However, when a filter requires Tableau to find all potential field values, this requires a complex query that can take time to evaluate. Here, using a wildcard may be more performant. The presence and maintenance of indexes in the data source can also dramatically help improve filtering performance. Parameters add interactivity and flexibility to a workbook. We can think of a parameter as a variable in an equation whose value can be controlled by the end user. Parameter controls, like shipping cost cutoff here, are sometimes confused with filters, like ship mode. However, filters trim down the data in the view, showing data only for the specified ship mode. Parameters simply provide a single output for another element, such as providing the reference value for the calculated field on color. Because parameters simply control a variable's value, they are only useful once that value is incorporated into something else, such as a filter, set, reference line, or calculated field. Changing this orphan parameter has no impact because this parameter is not tied to anything. It's like adjusting a dial with no wires attached. Parameters are not the same thing as filters, but they can be used in filters. Here we're looking at the top 10 customers by sales. However, we could let the end user decide what top number of customers they want to look at by using a parameter. Right-click on Customer ID and select Edit Filter. This brings us back to the filter setup. Click to the Top tab, and we see this filter was originally set as Top 10, but we can click on the drop-down here where it says 10 and change that to create a new parameter. Note that our pre-existing parameter shipping cost cutoff appears as well. Parameters are workbook-wide and can be used in multiple places. We'll create a new one and name this Top N, set the maximum to 10, and click OK. The parameter control automatically comes out into the view, and now we can adjust how many customers show. Parameters can also be used in the definition of a set. Here we're looking at a different data source altogether. Instead of filtering to the top N, we can create a set for the top N. Right-click on Product and select Create Set. We'll name it Top Products. Click on the Top tab, and just like before, we'll choose By Field, click on the drop-down beside 10, and we'll select our top N parameter. Now we'll bring Top Products to color. In this case, the parameter control did not automatically appear in the view, so we can right-click on the parameter and say Show Parameter Control. In our original view, looking at shipping cutoff, we use the parameter in a calculated field. If we right-click on that field, Shipping Cost Color, we can edit the calculation and see how it was constructed. We have a simple if statement. If our average shipping cost is greater than our cutoff, we'll call those orders high. Otherwise, call them low. That's all it takes to tie the parameter to the view. We use this calculation on something like color, and now the parameter control impacts the view. Note that the reference line automatically adjusts with the color as the parameter is changed. Let's recreate that reference line to see how we can leverage a parameter. Click to the Analytics tab and drag out Reference Line to Shipping Cost. For value, clicking on the drop-down offers us the relevant parameters. We'll pick Shipping Cost Cutoff and change the label to Value. Now that reference line is set to display whatever the parameter is set to. All of these examples have used numeric parameters. However, parameters support a variety of data types. Back on the Data pane, right-click and select Create Parameter. Data type options include float, decimal, integer, string or text, Boolean or true-false, date, and date time. Which data type is selected impacts where the parameter can be used and the display formats available. Our orphan parameter is a date, which is why that parameter did not show up in drop-downs that only supported numeric values.
A parameter is a global placeholder value, such as a number, date, or string, that can replace a constant value in a calculation, filter, or reference line. Dynamic parameters provide two enhancements to traditional parameters. The first is the ability to automatically refresh the list of parameter values when new values are added to the related data source column. The second is the ability to set the current value of the parameter based on a calculation. Let's take a look at an example. The viz displayed here shows sales values for the first few days in February. To the right is a parameter control based on the date dimension. Selecting a date sets the reference line to the sales value on that date. Let's see how we can make use of the new dynamic parameter capabilities. As new dates are added to our data source, we would like those additional dates to be listed in our parameter control. Additionally, we would like the parameter control to default to the most recent date in the data source when the workbook is opened. Let's edit our parameter to make it dynamic. Our parameter is currently set to display a fixed list of values based on the date dimension. Instead, we'll set the list of values to be refreshed automatically when the workbook opens. The default parameter value when the workbook opens is set to current value. Instead, we'll set that to the most recent date calculation in our workbook. Keep in mind that the calculation must be a single-value, viz-independent calculation. To confirm that our dynamic parameter is working, we first save and close the workbook. We then open the Excel file upon which our workbook is based. We add a date and a sales value, and then save and close the spreadsheet. Now, when we open our Tableau workbook, the dynamic parameter automatically refreshes. The parameter's current value defaults to the most recent date, and the newly added date is included in the list of parameter values. Parameter actions enable us to change a parameter's value by interacting with marks on a viz. The parameter's value could be a dimension or a measure. Parameter actions can drive reference lines, calculations, filters, and SQL queries. This makes Tableau vizzes more playful and interactive and extends Tableau's analytical capabilities. Let's build a few examples. To use parameter actions, we define a parameter, apply the parameter to an object, and then define a parameter action that will impact the value of the parameter. For our first example, we will create a grid with multiple panes where clicking on a mark will define the reference line value for the entire table. First, we create the grid by placing region and continuous month of order date on the columns. We place category and sum of profit on the rows. Name the sheet Interactive Reference Line. We would like a parameter to capture the profit value of the mark we click on. From the Dimensions drop-down, select Create Parameter. Name the parameter Threshold Parameter. We leave the data type as float and leave the allowable value set to all. Click OK. Next, we define the parameter action. From the Worksheet toolbar menu, we select Actions. Click on Add Action and then Change Parameter. Ensure that the source sheet selected is Interactive Reference Line. Run action on select makes the marks on the viz clickable. We set the target parameter to the threshold parameter we defined earlier. We set the field to sum of profit with aggregation set to sum to cause the profit value of the mark that is selected to be assigned to the threshold parameter. Click OK twice. Lastly, we define the reference line that will intersect the y-axis at the profit value of the threshold parameter. From the Analytics pane, drag a reference line to add it to the table. Ensure that the scope is the entire table. Set the value to threshold parameter, set the label to value, click OK. To test the parameter action, we click on a mark of the viz. The parameter action causes the mark's profit value to be applied to the threshold parameter, which, in turn, affects the position of the reference line throughout the entire table. For our next example, we'll create a crosstab that drills down to the subcategory level based on the category that is selected. First, we drag category to the rows and then right-click and drag average sales to text. Name the sheet, drilling down on a crosstab. We would like a parameter that captures the category we click on. From the Dimensions dropdown, we select Create Parameter. We name our parameter Selected Category, set the data type as string, set the current value as none, and leave the allowable values set to all. Click OK. Next, we define a calculated field that will become our subcategory drill-down dimension. From the Dimension dropdown, select Create Calculated Field. Name the field Subcategory Drill-Down and enter the following formula that will return the subcategory values for the selected category only. Click OK and drag the dimension to the right of the category field on the rows. Next, we define the parameter action. From the Worksheet toolbar menu, select Actions. Click on Add Action and then Change Parameter. Ensure that the source sheet selected is drilling down on a crosstab. Run action on Select. We set the target parameter to Selected Category. We set the field to Category so that the category we click on will be assigned to the Selected Category parameter. Leave the aggregation set to None and click OK twice. To test the parameter action, we click on any row of our viz. The parameter action assigns the corresponding category to the selected category parameter. The parameter value is then used by the subcategory drill-down calculated field to display the subcategories of the selected category. Parameter actions also enable us to aggregate the values of multiple marks we select within a viz. In this example, a reference line will display the average sales value of the multiple subcategory marks that we select. First, we drag sum of sales to the rows, sum of profit to the columns, and subcategory to detail. Name the sheet, retrieving a selection's average sales value. We want a parameter to capture the average sales value. From the Dimension dropdown, select Create Parameter. Name the parameter Selection's Average Sales Value. We leave the data type as float, set the display format as currency standard, and leave the allowable values set to all. Click OK. Next, we define the parameter action. From the Worksheet toolbar menu, select Actions. Click on Add Action and then Change Parameter. Ensure that the source sheet selected is retrieving a selection's average sales value. Run action on Select. We set the target parameter to selection's average sales value. We set the field to sum of sales with aggregation set to average to cause the average value of the selected marks to be assigned to the target parameter. Click OK twice. Lastly, we define the reference line that will intersect the y-axis at the average sales value of the target parameter. From the Analytics pane, drag a reference line to sum of sales for the entire table. Set the value to Selection's Average Sales Value. Set the label to Value. Click OK. To test the parameter action, we drag the mouse across the viz to select multiple marks. The parameter action then averages the sales values of the selected marks and assigns the average to the parameter. The parameter then drives the position and label of the reference line.
The Marks card has many options for formatting, including color, size, mark type. Even if there isn't a field on one of these shelves, it's possible to click on the shelf and adjust the property. For example, in this view, nothing is encoded by size, but we can still increase the size of the marks. The color shelf controls the color, but also things like borders. Labels have a lot of options. Let's click on the shelf to open it. Ticking this box will turn labels on in the view, the same as clicking the label button in the toolbar. We can alter the displayed labels to reflect what we want. Dragging a field to the label shelf adds it to the label and makes this text option available. Clicking on the ellipses here will bring up a full text editor. This is a powerful window, but only fields that have been added to the label shelf are available to use here. Labels can be turned on for specific actions, such as highlighting, or for specific points, such as minimum and maximum. And they can also be applied across the entire table, per pane, line, etc. It's also possible to turn on or off a specific mark label in the view by right-clicking on the point, going to Mark Label, and choosing the desired behavior, such as Always Show. For most views, there's a limited amount of space in the view for labels. Often, the best way to add additional information is through the use of annotations or tooltips. Annotations are text boxes used to call out a specific marker point or an entire area in the view. A mark annotation stays with the mark itself, regardless of whatever changes are made on the view. A point annotation stays in the same relative position on the view, independently of the mark, as does an area annotation. To add an annotation, right-click and select Annotate. We'll choose Mark. Like labels, marks can have fields added to them as dynamic inputs. The size, position, and format can all be adjusted. Single-clicking on an annotation brings up handles that let us control the dimensions and position. To format the text of an annotation, simply double-click on the text to bring up the editor. Or we could also right-click and select Edit. To format the annotation, right-click and select Format. The box can be adjusted in several ways, as can the line. Edit and Format can both impact the visual of a feature, but they control different things. Edit is usually content. Format is generally layout. If you're ever having trouble finding a specific element, and both Edit and Format are available, try checking the other place. Tooltips can be a powerful analytical tool, providing additional information when the viewer hovers over or clicks on a mark. Tooltips are very customizable. Here's an example of a heavily formatted tooltip providing a lot of information. Any fields in the view can be displayed in the tooltip. Fields not part of the view can be brought to the tooltip shelf. We could say something like, this mark consists of, insert the number of records, records. If the command buttons are undesired, they can be toggled on or off with this checkbox here. Tooltips are often underestimated as a part of the analysis, but they can convey a lot of information very compactly. Many parts of the view can be independently formatted. To see if a number, legend, or other part of the view can be formatted, right-click or bring up the menu to see if the format option is available. For example, hovering over a filter brings up the menu option in the header. Many aspects for the layout of the interactive filter can be controlled directly from this menu. But if we click Format Filters, the Format pane opens, offering us various options for font, alignment, etc. The options we see will vary based on what we're trying to format. To adjust the layout of an axis, right-click and select Edit Axis. This dialog controls things like the range, tick mark, and title. We can edit the range, say, upping it to 115. We can make the tick marks every 50 units. And back on the axis, we see those changes. Additionally, this pin icon has appeared. This indicates the axis is no longer automatic. Double-clicking will bring back that dial. If we add a dimension in front of shipping cost, such as order priority, we now have an axis per dimension. When we right-click and select Edit Axis Now, these options now make a little more sense. uniform axis range for all rows or columns, or independent axis range. If we select independent, Tableau will automatically rescale the axes per pane. To hide an axis entirely, right-click and uncheck Show Header. Right-clicking on an axis and selecting Format will open the Format pane. This allows for visual controls of what the tick mark looks like, the fonts, alignments, etc. Let's turn the profit axis back on, and if we click from one axis to the other, note how the Format pane reflects whatever we've clicked on. Here the ticks are green, and here they're default. The Format pane persists across tabs and can be manually closed with the X at the top. When working with maps, there are map-specific formatting options available. The marks on the map themselves were formatted on the Marks card, but to format the underlying map, click the Map menu, then select Map Layers. Here we can change our map style: dark, light, or normal. We can control the washout and control map layers such as borders and names. Some map options, such as streets and highways, can only be turned on when the map is sufficiently zoomed in. If there's a subset of map layers we want to use regularly, we can click Make Default. These settings will apply by default to any new maps created in future workbooks. We can open the Formatting pane from the Format menu. This gives us easy access to specific aspects of formatting, such as font and alignment. Or by right-clicking on an element in the view and selecting Format. Either option will bring up the Format pane, which opens over the Data pane and needs to be manually closed when formatting is complete. The Format pane is contextual. It changes based on the item being formatted. Here it's on Market, which is the field whose header I clicked on. If we click around, whatever is selected will be the element that the Formatting pane pertains to. If we click in the white space of the view and select Format, here is the non-field specific layout, the same as we'd get from the Format menu. First, we see the types of format settings: font, alignment, shading, borders, and lines. Font allows us to control things such as the font itself, size, and color. Let's set the worksheet font to be Times New Roman, size 10, and red. We can independently control things like the tooltip and totals. We're currently on the Sheet tab. Alternatively, we could work independently with the rows or columns and have our changes apply only at that scope. Once we've modified an option, that control becomes bold. This is an easy way to keep track of what changes have been made. It's also possible to clear any modifications down at the bottom of the pane. Our next formatting choice is alignment. Clicking on the drop-down for Default Pane, we see our options include horizontal, direction, vertical, and wrap. Pane controls the alignment inside the pane, such as mark labels. We'll make our pane direction vertical. Headers are things like the market and country names. We'll align those to be centered. Note that as we go along, often this isn't how we should format things. We're just trying to make it clear what's being impacted by each type of formatting. So we'll just clear this using the button at the bottom. Next is shading. Here, the new options are row and column banding. We can set the color for pane or header. Let's make them different so we can see what's going on. The band size here on the first tick mark makes the band shading alternate every other. The second tick is groups of 2 and 3, etc. The level is where the bands are grouped. Here it's at the country level. Adjusting the slider makes the grouping at the market levels. And now we need to bring it back down to every other to be able to see what's going on.
Which field is considered the header depends on the level of the banding. If it's shaded at the market level, market is the header. If it's shaded at the country level, country is the header. We'll clear this out so we can see what comes next. Let's format our borders. Borders are the lines that surround the table, pane, headers, etc. We can see what each piece does by playing with it. Let's make our default header a thin, dashed, gold line. Note where that impacts the view. For clarity, we'll turn it back to none. What about the row and column dividers? Pane, again, is the view. We'll set it to be a dotted orange line and make it a little thicker. Note that the header will automatically match, though this can be adjusted manually. The level, again, controls where the divider goes. Here it's between the markets. If we bring it up, now it's between the countries. The column divider is much the same. Watch the line between the order priorities at the top of the view. Let's turn off the default header line. Note that the line between the order priorities went away, but we'll clear this again. The last of our major formatting choices is lines. Lines are easier to see on a scatter plot, as they include items such as grid lines, zero lines, trend lines, etc. Let's make our grid lines green, our zero lines dashed, our trend line nice and thick, and reference line we'll make dotted. A common confusion is between border, the box here, and lines. For example, grid lines in a scatter plot may look like the box icon, but they're not borders around cells or panes. They're lines, so they live under the line icon. Another way to clear all this formatting is by coming to the Clear Sheet icon and selecting Clear Formatting. Once we've got a worksheet formatted exactly as desired, it's often easier to be able to carry that formatting through to other worksheets. Here's a scatter plot formatted just how we want it. We also have another scatter plot. We want to have the same formatting we did on the first. We'll right-click on this Sheet tab and say Copy Formatting. Right-click on the destination and select Paste Formatting. Note what is copied and pasted. Worksheet formatting only. The mark type, colors, sizing, and reference lines are view-specific, so those don't transfer. But the axis formatting and things like lines did copy. A quick way to remember this is that formatting done in the Format pane will copy and paste. Formatting done in the View will not. Finally, we can set the font at the level of the workbook. Click on the Format menu and select Workbook. Here we can control all the fonts in the workbook for a unified, consistent experience across the entire workbook.
Tooltips are an often overlooked but very powerful part of Tableau. By default, the various fields used to create a viz are added to the tooltip. Hovering over a mark provides that underlying information. This is useful, but tooltips can be so much more. I like to make my tooltips tell more of a story. My usual way to format tooltips is to change the default to a sentence. For this viz, I describe it to someone as, in Q4 of 2012, technology sales were this. So why doesn't the tooltip say it? Well, it can. We'll click on the tooltip shelf to edit, and we'll start a new tooltip. We can type in, and then cut and paste the field quarter of order date. Note that we have to take the angle brackets with the field name. That's what lets Tableau know this isn't the literal string quarter parentheses order date, but rather the value, Q2, Q3, for that mark. And we'll paste it where we want it. We'll type of, and then bring up year. A comma. And then another way to put a field in place is to use the Insert menu. Anything in use in the view can be added from here. We'll put in category. And then type sales were, and we'll insert sum of sales. And we can delete all the defaults and labels. We can preview and see, yep, it looks good. I'll add a $sign in front of sum of sales. We could format the field itself to be currency, but sometimes this is easier. As we mouse around the view, we realize it's not always clear what to look at in the tooltip. Let's click on the tooltip shelf again and select sum of sales and change it to be size 12, and we'll use a more bold font. We can also add fields to the tooltip that aren't in the view by bringing them directly to the tooltip shelf. On the Marks card, there's now a tooltip icon in front of sum of profit, and in the tooltip, we can add for a profit of, and then insert sum of profit. That looks pretty good. Here we have a bar chart that shows shipping cost by year and ship mode, and each year's bar is broken up into quarters. If we bring up the tooltip and click to make it persist, when we move the mouse, we can click on various pieces of the tooltip, wherever there are discrete fields that we use to build the view. We can highlight all standard class orders, all orders for Q2, or orders for a given year. It might not be intuitive for my end users to know what they can click on, so I'll modify the tooltip and add a comment at the bottom. If we don't want this functionality to be on, we can uncheck the box, Allow Selection by Category. You may have noticed that when I clicked to freeze the tooltip, we did not get the command buttons popping up. Usually, if we leave the mouse over the same mark for a moment, or click, the command buttons come up. These buttons let us act directly in the viz by keeping or excluding specific marks or groups of marks, creating groups or sets, or we can view the underlying data making up the mark. Command buttons can be useful in many situations, but we may not want the user of a viz to be able to access all these features. To turn off the command buttons, click on the tooltip shelf and uncheck Include Command Buttons. We can also choose not to show any tooltips at all, or to show them only if we hover over the mark for a moment. Now let's get a bit more technical. This tooltip, when we click, has a link at the bottom. This is an action. Actions enhance the interactivity of a viz by highlighting, filtering, or opening URLs, depending on how they're created. Actions can be triggered directly in the view by hovering or clicking on a mark, or set up to show as links in the tooltip like we see here. For more information on actions themselves, check out the video on dashboard interactivity with actions. For now, just note that the text that shows in the tooltip for a menu action, like we have here, is set by the action, not in the tooltip editor. There's no link there. And if we click on this link, we're brought to an entirely new sheet. When the mouse moves over different bars here, watch the order priority at the bottom. See how it changes to match the colors of the bar chart? How is that done? This isn't quite as straightforward as some of the other uses of tooltips, but it can be done fairly easily. The key is to create a new field for each possible option that needs its own color. Here there's a field for critical, high, etc. If we right-click and edit, we can see how this calculation was made. The calculation simply says, if the order priority of the field is low, then return the order priority. Otherwise, and this is just a double quote with nothing inside them. This means that if the order priority is not low, the calculation will return nothing. The other three calculations are the same thing, just with the other options here. If we go to the tooltip, we can see that these 4 fields were inserted, like we did before, immediately one after each other. Because only one order priority can be true for each order, the 3 that are false will show as nothing, and only the true value will appear. It's then simply a matter of coloring each field as desired. I used the More colors and then Pick Screen Color to match the color legend. Tooltips are a powerful way to enhance a visualization or analysis by providing additional information when hovering over a mark. For general information, check out the video on basic tooltips. With the Viz in Tooltip feature, you can put a secondary target visualization into the tooltip of a primary source viz. When you hover over a mark, the visualization in the tooltip is automatically filtered to just the relevant data. Placing a viz in a tooltip is easy. Start by creating both sheets. Then, from the main source viz, click the tooltip shelf to bring up the dialog. From the Insert menu, choose Sheets, then select the target sheet that should appear in the tooltip. Click OK. And now when we hover over a mark in the source viz, the tooltip displays the target viz. When you create a viz in Tooltip, you want to consider the size. If the target viz is too large, the tooltip will indicate View is too large to show. By default, the target viz is 300 by 300 pixels. We can edit the tooltip to manually change the size if we choose, but be careful that it doesn't detract from the main visualization. We recommend not going over 600. Alternatively, we can go to the target sheet and set it to show entire view instead of standard. This will ensure that it adjusts to fit the allowed dimensions in the tooltip. This should be used with caution to ensure that the viz is still readable. A tooltip can contain more than just the target viz or vizes. We have the ability to customize the tooltip around the viz for things like formatting and additional content. Here, we can provide some context. We can use the Insert menu to add fields so the values appear dynamically. And we can turn off the command buttons. However, some edits must be made on the target viz itself. Here, I think the axis title of Sales is unnecessary with the added text above, so I want to turn it off. There's no option in the Tooltip dialog that lets us do this. Instead, we have to go back to the target sheet and edit the axis, removing the title here. Changes to the viz used in the tooltip must be made on that sheet. On the sheet for the target viz, we can see 2 things. 1, the viz as it appears is much larger than the tooltip, and 2, there's a tooltip filter on the filter shelf. When a tooltip containing a viz is displayed, the target viz is filtered based on what mark we're hovering over in the source viz. By default, the target viz is filtered by all fields. What this means depends on how the source viz is built. For example, here, each mark is the number of countries in a given region. The target viz is the category sales for each of those countries. So as we hover over different marks, the target viz is filtered to category sales for only the countries in that region. If we were to add something like category to color on the source viz, we go from 18 to 54 marks. Each color in the stacked bar is now a mark of its own, and the target viz in the tooltip is now filtered to just the sales for that category for the countries in this region. We can use how the sheets are built to control how filtering occurs, or we can specify a certain field or fields. In the Edit Tooltip dialog, we can replace the filter option. Here, so instead of saying all fields, we'd insert a specific field, such as region. Now in the view, the target tooltip is only filtering to show countries in that region and displays all three categories, regardless of which mark in the stacked bar we're hovering over. Here's an extra little tip. Although we can't bring a color legend into the tooltip with the target viz, we can get creative with text formatting. We know that the target viz has three colors, representing technology, office supplies, and furniture. We can then use the text color, picking more colors, and then picking a screen color to have each category's name be the color it appears. Now back on the source viz, we can take category off color because it's cluttering up the view. And the tooltip still conveys that color legend information. Finally, note that the viz in the tooltip is a static image, not an interactive viz in its own right. A target sheet can also only be used in a tooltip for one source sheet at a time, though multiple target sheets can appear in the same tooltip. Filtering on specific fields can only be done from within a single data source, and only sheets, not dashboards or stories, can be shown in tooltips.
Trends can provide important insight into an analysis. For example, here answering the question, by how much does our power output go up with wind speed? We can see the relationship here that when wind speed increases, the power output increases, but how exactly? It's easy to add trend lines to the view. Click into the Analytics pane and drag trend line to the type of model you desire. Removing trend lines is just as easy. Simply drag it off the view. But we want our trend line, so let's undo that. By default, trend lines are per pane and per color. Back on the Data tab, if we bring another dimension into the view, such as location, we get a trend line per pane, or per scatter plot. Similarly, if we were to move location onto color, our trend line breaks out into three. If we want to see our locations on color but only have one overall trend, we can modify the trend line. Editing the trend line takes a simple right-click, select Trend Lines, Edit Trend Lines. Unchecking Allow a Trend Line per color will bring us back to a single overall trend line. We can also uncheck Show Confidence Bands to simplify the view. There are several other things we can do with this dialog box. First is the model type. These are the same options as when we first bring out trend line from the Analytics pane. These options tell Tableau to build a linear regression model based on this type of transformation on one or both variables. Linear refers to the coefficients, not the relationships of the variables. For information on the model types and transformations, the online help article on trendline model types provides some excellent information. The confidence band shows the 95% confidence interval for the model, and we also have the option to force the y-intercept through 0. It's important to assess if a trend line provides valuable information. Hovering over the trend line brings up a tooltip with the trend line equation, the p-value, and the r-squared. In statistics, the p-value is the number assigned to the concept of significance. If the p-value is less than a cutoff value, usually 0.05, the results are interpreted as significant. A large p-value, on a scale of 0 to 1, can indicate that the apparent trend in the data is due to chance, not the factors in the model. In this example, the trend line has a very small p-value, which is good. However, to correctly assess if a model is a good fit, we need to know more than the p-value. We also have the r-squared, which effectively tells us how the model fits the data. R-squared values can range from 0 to 1, and higher values are considered better. We see in our example that the R-squared is very high, at 0.956. This means our model fits the data very well. An R-squared of 1 indicates a perfect fit. But beware if your R-squared is incredibly high, for example, 0.999. Your model may be misleading. A common indicator of an artificially high R-squared value is low degrees of freedom or just having too many observations. To decide if a trend line accurately represents the data, it's not enough to have a small p-value or a large R-squared. Not all of our points will fall on the predicted trend line. The distance from a given point to its predicted value is the error, or residual. In a correct model, those residuals should follow a random normal distribution around the zero line when plotted against the explanatory variable. If this residual plot is not normally distributed, it indicates that there are trends in how the data fail to line up with the predicted values, which means the model isn't the best. To get the residual values for a trend line, go to Worksheet, Export, Data. This will prompt us to save the file. The only format option is Microsoft Access, and we'll name it Trendline Residuals, and hit Save. We'll choose Connect After Export. This data source has the original data from our scatter plot, as well as the predicted values from the trend line and the residuals. The residual plot is constructed as the explanatory variable on the x-axis, wind speed goes on columns, and the residual on the vertical axis, on rows. And we'll bring windmill to level of detail. Remember, a good model has a normally distributed scatter around 0. Clearly, our current model isn't very good at predicting our power based on wind speed values. Although the p-value and R-squared for the trendline are good, the residual plot is pretty awful. That's an overview of trend lines in Tableau and how to interpret the relevant statistics around them. Reference lines do exactly what it sounds like they'd do. They add a point of reference to a view. Reference bands or boxes can also be added to shade a specific area or distribution in the view, and multiple reference lines can be added to the same chart. Adding a reference line to a view is quite easy. Click the Analytics tab for a list of drag-and-drop options. We'll choose Reference Line and have it broken down by table. If we select specific marks in the view, the reference line will temporarily update to indicate the reference for just those marks. Let's remove this line and redo it, this time using Pane. If we like what comes out automatically, we can dismiss this dialog. However, there's a lot we can control here. The Analytics pane gives us the same options at the top. We'll go over reference lines, then look at the differences for the other options. First is Scope. Scope is set to per pane, but it can also be across the entire table or per cell. If we click Entire Table, we can see that the average line switched from 3 different lines, per category, to a single average across the entire table. Next, we can adjust the line itself. We'll make it a median profit line. Value lets us select which measure we want the line to be in reference to. Here we have both sales and profit in the view, so we can select either of them. Let's change it to profit. The default aggregation for the line is average, but we can change that, and here we'll go with median. Next is label. Here we set what shows as the label on the line. None is fairly self-explanatory. Value displays whatever the value of the aggregation of the measure is, so the actual numerical median of profit. Computation displays whatever the aggregation of the measure represents, so here it will be the words median profit. Custom gives us the option to type in whatever we want, and the arrow to the side offers fields that can be inserted. We'll use value, computation, of field name. Whoops, I clicked OK, but I wasn't done.
let's get back to that dialog box. We can right-click on the reference line. It helps to not be over a mark. And select Edit. If we click Format instead, we'd be able to control the format of the line and label. But here in the Edit dialog, we can do some basic formatting of the line, and we'll make it dotted. A constant line can be brought out directly from the Analytics pane. We're prompted for the value, and here we'll make it 500,000. Formatting options were available by right-clicking on the reference line, but we can also control them by going to Format, Reference Lines. As you can see, there are a lot of options here. We can also right-click on the axis to bring up the Edit and Remove options, add another reference, or if the field in the reference line isn't the main measure in the view, we can swap the fields. This can be handy when modifying views built by ShowMe. On the Analytics pane, we have the option to select Line, Band, Distribution, or Box Plot, if the view allows. Lines are constant or computed values at a single value per line. Bands shade the area behind the marks with two values, either constant or computed. Distributions add gradient shading, which is great for things like bullet charts. And box plots show the quartiles and whiskers. When setting up a reference band, we'll bring this to Pane. The only real distinction from a line is that two values need to be determined, the upper and lower cutoffs. The defaults are minimum and maximum, but we could set it to be median and average. And we'll turn off the label for average. Now we can see which areas have these two measures of central tendency differing substantially, which could indicate skew in the data. Distributions, just like all references, can span the entire table or be per pane or per cell. The computation, however, is where distributions start to differ. For detailed information on the options and how to control the layout of reference distributions, check out the online help article below. It's also worth noting that reference distributions are used in building bullet graphs. Bullet graphs are available in ShowMe and combine a reference line with a distribution. Box plots are fairly straightforward. They're a common way to show statistical distribution. We can set the whiskers to be 1.5 times the interquartile range or to the max of the data. We can tweak the visual, hiding data that would be under the box plot and formatting the box and whiskers. Box plots are also available in ShowMe. Another option in Tableau are drop lines. They're similar to reference lines in that they call out a value on an axis, but drop lines are tied to the mark in the view. Let's turn on drop lines by right-clicking in the view and selecting Drop Lines, Show Drop Lines. Now when we select a point, the lines are dropped to both axes for the values of that mark. We can edit drop lines by again right-clicking in the view, selecting Drop Lines, Edit Drop Lines. We can control if the line goes to one or both axes, if the drop lines are always shown or just when the marks are selected, and if the value is labeled. Now when we click on a mark, we get a labeled drop line just to the y-axis. Drop lines can also be used on other chart types, such as bar charts and line graphs, as seen here.
Explain Data automatically provides AI-driven explanations for the value of a data point with a single click. Based on advanced statistical models, explanations are relevant and integrated, saving us time and enabling us to uncover insights we may not have found otherwise. Explain Data works when authoring in Tableau Desktop, Tableau Server, Tableau Online, and Tableau Public. It is available to users with Creator and Explorer access. Use the workbook below to follow along. Our workbook contains data on London house sales. The viz displays the average duration of home ownership broken down by borough. Most boroughs have an average home ownership duration greater than 5 years. However, the borough of Newham is an outlier with an average home ownership duration of only 4.8 years. We will use explain data to help us explore why homes in Newham are selling more frequently than in other boroughs. To use explain data, we must select a single mark to analyze while editing the view. Our viz must contain a measure that is aggregated with sum, average, count, or count distinct. In our scenario, we click on the mark that represents the average duration of home ownership for Newham. We then click on the Tooltip icon for explain data. We can also launch explain data from the analysis menu or by right-clicking on the mark. The explanations window displays the name of the mark we selected, the measure in use, and an expected value summary. This information confirms that the average duration of home ownership for Newham is lower than expected and is not within the natural range of variation. Below that, on the left, we see several possible explanations for the expected value summary. These explanations are listed in order based on how informative they are. The explanations are based on all the dimensions and measures of our data source, not just those displayed in the viz we are exploring. To the right, we see the explanation's description displayed as a combination of Tableau-generated natural language sentences and Tableau vizzes. Our first and most informative explanation is that Newham has a distinctive ratio of records with residential group equal to young ethnic communities. In the explanation description, the blue bars in the chart represent Newham, while the gray bars represent all boroughs in the map. The y-axis represents the percentage of total number of house sales. The gray bars tell us that across all London boroughs, a lower proportion of house sales occurred in boroughs with young ethnic communities. Meanwhile, the blue bars tell us that in the London borough of Newham, a higher proportion of house sales occurred in young ethnic communities. As we scroll down, we see that the average duration of home ownership throughout London is slightly lower in young ethnic communities than in all other categories. However, this average is still not as low as the 4.8 average for Newham. Let's explore one of the other explanations for additional insights into the outlier. The second explanation is regarding housing affordability groups. Again, the y-axis represents the percentage of total number of house sales. The blue bars tell us that Newham has a high proportion of house sales in the extremely low housing affordability group, in contrast to London overall. The third explanation is regarding median age. At the median age of 32, a higher proportion of house sales occur in Newham than in London overall. At other median ages, Newham has a lower proportion of house sales than London overall. The fourth explanation indicates that almost all the house sales in Newham occur among those who are not retired. Explain data is a jumping-off point for further exploration of our data. Each viz within the explanation description can be opened as a new worksheet for further analysis. Let's open our Distribution of Values for Percentage of Population that is Retired viz as a new worksheet to examine it further. Let's swap out Percentage of Population that is Retired, replacing it with Median Age. We see that all the house sales in Newham are among relatively young people. Young people are generally quite mobile and move more frequently than older adults. This may help explain why the average home ownership duration in Newham is lower than the rest of London. We started our analysis by asking explain data why homes in Newham sold more frequently than in the rest of London. Explain data analyzed our entire dataset to quickly uncover relationships within our data. We then use those insights to help guide our deeper analysis of the data.
Forecasting means using a statistical model to generate predictions for future data based on historical information. It's very easy to build a forecast in Tableau, though there are some constraints we'll cover at the end. All we need is a date and a measure, and then, from the Analytics tab, bring out Forecast. The view will have both the forecast and prediction intervals, the shaded band, by default. If we change the mark type to a circle, the prediction interval becomes whiskers around the point. Tableau uses exponential smoothing to generate a forecast based on the data in the view. Here we have a forecast of shipping cost across the months of ship date. The model selection is automatic, but there are some things that we as the user can adjust. If we want to customize the default forecast, right-click in the view, select Forecast, Forecast Options. Forecast length sets how far in the future the forecast will extend. We could make it exactly 3 months. Source data has a handy option, Ignore Last. This is good to use when a portion of relevant data is missing. For example, if we're aggregating to month but we're partway through the current month, we may want to trim what data is used in the forecast back to the last complete month. By default, Tableau ignores the last unit of aggregation, month, year, etc. The forecast model can be automatic or automatic without seasonality, which leaves everything up to Tableau, or custom. Custom brings up 2 further options: trend, which can be set as none, additive, or multiplicative, and season, with the same options. Unless you have a reason to change these, Tableau's automatic settings usually do very well. Information on additive and multiplicative models can be found in the online help article accessible by clicking this link. The last option is the prediction interval. The shaded area represents the range of values for the forecast with 95% confidence. That is to say, the statistical model thinks there's only a 5% chance the future value will be outside the shaded area. The more precise our confidence, the wider the band will be. Here we have a forecast of sales for various order priorities. If we want to see more information about these forecasts, we can pull up the description. Right-click in the view, go to Forecast, Describe Forecast. There are 2 tabs here. On the Summary tab, we can see the time series and measure used, how far the forecast goes and what date it was based on, including what was ignored, and if there's a seasonal pattern. We also get some additional information about the measure specifically. This table is broken out by the dimensions in the view. I like looking at the contribution by trend and season. 2 order priorities don't seem to have any real seasonality in their historic data, as well as quality, which indicates how well the forecast fits the existing data. The second tab is for the models. Tableau uses Holt-Winters exponential smoothing, and this tab describes the quality metrics and smoothing coefficients used in the model. Again, Tableau will automatically evaluate the data and apply the appropriate model. There is no way to alter the smoothing constants used. For a complete explanation of the information found in Describe Forecast, please see the online help article by clicking this link. Forecasting has some requirements. It needs at least 1 date, or a dimension with integer values, and 1 measure. At least 5 data points, and if the data is seasonal, at least 2 seasons worth of data. Forecasting also has some restrictions. Because of the nature of the forecasting models, forecasting cannot be done against a cube, on a view containing table calculations, totals, or subtotals, or on disaggregated measures or dimensions. Tableau can provide a lot of information about the forecast by way of the forecast field results. This feature is easiest to explain by showing it off. Here we have a forecast of profits across order date. If we click on the pill that has been forecasted, indicated by the thick upward arrow, and go to Forecast Results, we see several options. We'll bring a new copy of the forecasted field, Profit, to the tooltip. On this pill, open the menu and go to Forecast Results, and we'll pick Precision. We'll click on the tooltip to edit. Here where we have Forecast Precision, we'll insert that value. Now when we hover over a point in the forecast, we get that plus or minus indicating the size of the prediction interval. Another cool thing is this forecast indicator. Here in our timeline, we see the forecasted values in light blue. Let's duplicate this tab as a crosstab. We'll swap our axes,
and we'll move Forecast Indicator from columns to color. We can edit our colors to be a bit easier to read. We'll change the estimate to be orange. We can remove things that we don't care about as much. And now this crosstab shows our actual values in blue, and in orange, we get the forecasted value as well as the prediction interval. Cluster analysis is a statistical analysis technique used to identify which items are more related to each other than other items based on some characteristics. Tableau's clustering feature uses the k-means clustering method. Performing cluster analysis is a simple drag-and-drop experience. As long as the view supports clustering, simply click on the Analytics tab, drag Cluster to the box, and ta-da! Clusters are automatically put on color in the view. We can control the number of clusters and what variables are used to compute the cluster. Tableau automatically uses the fields it can from the view to make the initial clusters. Once the clusters are calculated, they are independent of the measures in the view. And to change what fields are being considered by the clustering algorithm, simply drag a field into or out of the variable box. The variable box can be brought up after the initial creation of the clusters by right-clicking and selecting Edit Clusters from the pill itself. To see more information about the cluster, click Describe Clusters. This brings up a summary of results. For more information on interpreting the information in Describe Clusters, click this link to bring up the online help. The cluster is created as a new pill on the color shelf, but that pill can be dragged into the data pane to be saved as a group. What other views support clustering? Well, the data can't come from a cube, but there are a few other requirements. The view must have at least one dimension, or, like we have here, aggregation has been turned off. Some fields cannot be used as input for clustering, including dates, bins, sets, and table calculations. OLAP or cube data sources use the MDX language rather than SQL to define calculations. This video does not teach MDX, but rather shows how to use it in Tableau. One of the many uses of calculated members via MDX is to define new groupings that were not created by the cube's architect. Here, we'd like to group some of the members of the subcategory office supplies together into a small items group. I've color-coded them orange in the view. Note that the version of Superstore used in this video does not match the other videos. If we select the desired items and bring up the tooltip, there is no grouping icon. We have to write a calculated member to define them as grouped together. Right-click in the data pane and choose Calculated Members. Press the New button under the first pane on the right. In the name box, we'll call this Small Items. Next, we'll define where the member belongs in the hierarchy. Rather than creating a new level of hierarchy like grouping using a relational data source, we're creating a new member within the existing hierarchy level that's composed of other existing members. We want this Small Items member to be part of Office Supplies in the product group hierarchy. So we'll select the product.product group hierarchy. Lastly, for Parent, choose Selected Member and choose Office Supplies. Now we need to write out the MDX to group these members together. I'm pasting in this calculation to save time, but you can see the basic MDX structure for putting dimension members together. Members of the hierarchy are referenced using the bracket and dot notation, and the plus sign says to bring them together. If you're following along, try and type in the first two. You can always complete the others later. Click the Check Formula button to make sure we haven't made any errors. The calculation's valid, so we'll click OK.
We now see there's a new bar in the viz for small items, and we still have the original subcategories that went into that bar. This is very different from a relational data source, but the cube also allows us to filter out these subcategories without affecting the new one. We'll select the ones we don't want and exclude. In the data pane, note that the product groups hierarchy has an equal sign to indicate we've created a calculated member in that hierarchy. A cohort calculation returns a measure when a dimension has a certain value. For example, we might make a West sales calculation that says if the region is West, then give us sales. If we try and create a calculated field using a cube data source, we cannot bring in a dimension. Only measures are available. For any logic based on dimensions, we must use MDX to create a calculated member. We'll create a new calculated member, just as before, right-clicking in the data pane and selecting Calculated Members. We'll click New, and this time we'll name it West Sales. This time we do want it in the measures hierarchy. And here's the calculation we'll enter. This is the syntax to return a specific part of the larger sales measure. We're asking for the sales member of the measure hierarchy, then placing a comma, then putting the place in the hierarchy we want to limit the sales to, in this case, the West region within the customer geography hierarchy. Unlike Tableau calculations, there are no hints or function names available for MDX calculations. You will have to learn MDX and know what your desired calculations and member names are on your own. However, all calculated members can be edited from this single menu. Cubes do not behave exactly like relational data sources. Rather than showing null for all the regions other than West, a cohort defined this way will still show value for all regions in the hierarchy, but the measure value will be identical for all of them. It will be the value for West only. Keep this in mind as you work with MDX and calculated members to get the results you want in Tableau. There are many other examples of uses of MDX and calculated members in the Tableau knowledge base.